Hello everyone, my name is Russ. I work with CapX Sales. We're located here in South Carolina. We also have some representatives up in North Carolina as well as Virginia. We've been working with Cincinnati Test Systems for 20 years now, at least I have. And so we often get a question about negative leak rates. So today I want to talk about negative leak rates, what that means, and how that occurs specifically on pressure decay applications. Now, if you remember any of our previous conversations or videos that we had regarding leak testing, specifically about pressure decay is volume dependent. And what that means is if you're testing a basketball and you pressurize it to 10 psi, and you're testing a tennis ball and you pressurize it to 10 psi, imagine a 5 SCCM leak standard in both of those balls and a transducer that's going to measure the pressure loss over time. You got 60 seconds. So in 60 seconds, which will lose the most pressure? Thinking back to physics. So if you said the tennis ball, you are exactly correct, right? The smaller volume, they're leaking at the same flow rate. So their flow rate is the same, 5 standard cubic centimeters per minute, but the pressure loss is going to be more significant in that same time, in that 60 seconds for the tennis ball, than it would be for the basketball. So that's why calibration for pressure decay instrumentation is so extraordinarily important. If you're calibrated to a tennis ball but you're testing basketballs, it just isn't going to work right. If you're calibrated to a basketball and you're testing tennis balls, it just isn't going to work right. So calibration is key to, well, a successful calibration is key to a repeatable application, repeatable test. So I'm going to talk to you a little bit about calibration, and then through that I'll explain how a negative leak rate can show up. So first, let's draw a little curve. Well, I'm going to draw a graph, and we'll draw a curve. This is going to be the test of our known good part. All right, so this is the fill time. This is the what we call the stabilized time or stab time. And this is going to be our test time. Okay, so we've got our fill, stabilize, and test. With pressure decay, of course, pressure decay, we're losing pressure over time. So what we're doing is we're pressurizing the part, and then we are isolating the part. So theoretically, you could disconnect the air pressure from the leak test instrument, and it's still going to test on the circuit that we've pressurized. Now, so that's pressure decay leak testing. When we do this, so this is our, let's say, our known good part. So we started our test here, and so we're measuring the pressure loss of our known good part through that section. So let's say it lost 0.015 psi. Okay? Now we're going to run a second test during the calibration. So we let the part relax and come back to a normal state, and then we're going to pressurize it again. And we're going to run the same test, but this time we're going to introduce the leak standard. So let's imagine we're testing the basketball, and we're going to repressurize that basketball, but now we're going to introduce a known leak. It is a 5 standard cubic centimeter per minute leak at 10 psi. This is what the curve might look like in that scenario. Okay, so this represents, this area right here represents the pressure loss as a result of the leak standard. The 5 SCCM leak standard that we introduced is represented in that pressure loss. So let's say it is 0.055 psi. So effectively, what happens with the leak test instrumentation is that 0.0, if we take the difference between those two, 0.040 psi equals 5 SCCM to the instrument. So that's what it did. It's established a ratio between pressure loss the pressure loss and the leak standard that we've told the instrument the leak standard is this value, so it knows what to correlate that value with. When you get a negative leak, what is happening is you're not necessarily gaining pressure. What has happened is, to the instrument, this 0.015 psi equals 0 SCCM, because it essentially tears out the pressure loss of a known good part. So 0.015 psi equals 0 SCCM. So what happens is, when we run a test and we lose, say, 0.01 psi, the instrument can only display that as a negative flow rate. So it lost less pressure than the part that we calibrated to. So the only way that the instrument can display that is as a negative number. So just keep that in mind. It's okay to have negative leak rates when you have a pressure decay calibration setup. It's very common, but that value should be right around, negative, say, no greater than negative 0.5 if you've got a great calibration. If it gets to be more than that, then that can mean that there are other issues going on. So for example, if you are using a connector that is activated with air, if that connector is leaking, it could leak into the part. If it leaks into the part, what's going to happen is the pressure is going to rise in the part, and that's going to cause a very negative leak. So in that case, we'd say you've got that going on, or even that going on. So we are increasing in pressure. This is going to be a very negative. We're talking negative 10 SCCM. So that's something to keep in mind with pressure decay leak testing. Why are you getting negative numbers? This is the reason for the negative numbers, is the part you are testing after the calibration is testing better than the part you calibrated to. Again, my name is Russ. I'm with CapEx Sales. We represent Cincinnati Test Systems here in the Carolinas. We also work with Symmetric, which is owned by Cincinnati Test Systems, and Schreiner, which is a German company that is also owned by Cincinnati Test Systems. Please visit us at capexsales.com for more information and more videos like this to help you become better at what you do every day, if it is leak testing or automation. Thank you.